And as soon as this is up, it's thinking about it. There we go. So we're looking at unit 4, which is on rationals. And rationals simply mean a fraction with variables. Like that's the simplest definition of what we're going to be working with for this unit. So let's try that. Not sure why this is not hiding itself here. Hopefully that will hide itself in a little bit. But in any case, rational expression is a fraction with variables. Typically with variables on the bottom. So the rational expression is undefined when the denominator is 0. What does that mean? Everybody grab a calculator, grab your phone, do 5 divided by 0. 5 divided by 0. And it gets like a little E or something on the side with the little basic calculators. Anybody try their phone? What does your phone say? Error. So it doesn't work because you can't take something and cut it into no pieces, right? We're dividing, we're cutting into sections. You can't cut something into no pieces. That doesn't work. It will always give you an error. There is no answer there if you're dividing by 0. And so we need to pay attention to that when we're dealing with fractions. We can't have the denominator be 0. And so any number, if you plug it in for a variable that would make the denominator 0, we're going to call an excluded value. So these are all kind of on the side of your notes there. So functions with variables, that's a rational expression. Rational expression is undefined when the denominator is 0. And the number can be substituted for the variable. So if I plug a number into the variable and it makes the denominator 0, it's an excluded value. I can't use that number because it's going to give me an error. It's going to give me something that doesn't work. Now, the rest of this down here says add. You can add this into your notes if you need to. This is all stuff that you would have learned back in Math 1. Maybe you saw it again in Math 2. But as a quick reminder, if I have x squared times x cubed, that's the same as x to the 2 plus 3. You add those exponents together, which makes x to the 5th power. If I have x to the 7th divided by x to the 5th, that's going to mean 7 minus 5. You subtract the exponents. So here, x to the 7 minus 5 is going to be that x squared because I subtract those exponents. If the bottom number is bigger, if the bottom exponent is bigger, x to the 5 minus 7 there, that would be x to the negative 2 power. And that's actually what we're talking about right here with the next rule. If I have a negative exponent means my answer is going to be the reciprocal. It's going to flip upside down. So I believe Mr. Kaiser, just right next door, at least some of the students have told me in the past that he described these as a ticket. If you're on the top floor, your ticket to the bottom floor. When you use that elevator, when you go down, your ticket's punched, it's gone, you don't have it anymore. You've used up your ticket. And so it becomes positive. Same thing if you're on the bottom, you go up to the top, ticket's punched, it's not there anymore. You don't keep going back and forth and back and forth. You go one time and the ticket's gone. Does that make sense to everybody? So x to the negative 2 is the same thing as 1 over x squared. The reciprocal, but now positive exponents. X to the 0. This we've mentioned a couple times before. Anything to the 0 power. Anything to the 0 power is 1. Doesn't matter what it is. X to the 0, 10 to the 0, a million to the 0 power. Anything to the 0 power is 1. Are we good there with those exponent rules? So let's try it. Everybody go ahead and look at the couple examples here at the beginning. we've got 21a squared over 7a cubed. Take the numbers out in front and treat them like a fraction. 21 over 7. Well, 7 goes into 21 3 times. So 3 over 1, if you want to put the over 1, that's fine. A squared over a cubed. If you need to, you can write that out. That means 2 a's on the top, 3 a's on the bottom, cross. I'm going to try it real hard to not say cancel. It's, again, second, we've used that term a lot oftentimes, but really what's happening here is that it is simplifying down to 1. It's reducing. Back in Math 1, you may have heard them use the term like strategic 1 or a big 1, something like that, saying that these two things, a over a, reduce to just 1. Does that idea make sense to everybody? So I'm left with a single a on the bottom. So really, this whole thing reduces to 3 over a. But now you'll find I do this a bunch, and you guys will probably do it as well. It's easy to just get started on the problem and solve it. And then realize, wait a second, I need to find the excluded values. And this would be easier to see if this little menu would, I don't know why it doesn't want to click away. I don't know. Can't get it to disappear. What if I move it down here? At least now it's out of the way. So with this, it says state the excluded values. That means anything that's going to make the denominator equal to 0. In this case, there's an a on the bottom. There were actually, what, 3 a's on the bottom. If I put 0 into a, 7 times 0 to the 3rd power is going to be 0. So I need to say right here that a cannot be 0. Because if it is, I'm dividing by 0, and that's an error. It doesn't work. If I do that same thing for number 2, I can actually say the excluded values at the very beginning. Before I do anything else, I can look at the denominator here and see, okay, I've got an a, a b, and a c. So that means a cannot be 0, b cannot be 0, and c cannot be 0. Because if any of them is 0, the whole denominator is 0, and I'm dividing by 0, and that doesn't work. So now we can simplify, take the 36 over 12, right? 36 over 12 is going to reduce. 36 divided by 12 is just 3 again. So I'm going to have 3 on the top. A to the 4th over a squared. Let's use a different color here. So if I want to reduce the a's right there, a to the 4th over a squared could cancel out, sorry, reduce 2 of them. A over a, 1, a over a, 1, but then there's 2 a's left over. Those 2 a's stay on the top, right where they were before, right? There were more a's on the top to begin with. So any leftover ones are on the top. The b's, b to the 2nd over b to the 2nd. What happens to those? They're gone. It reduces us down to 1, right? There is no b left over. So I don't need to write it. And then the c's, does that make sense? So we cancel out, again, reduce 3 c's. We have 3 left over, but they are on the bottom. Now, my excluded values, a cannot be 0, b cannot be 0, c cannot be 0. I still have to have all of those, even though there's not even a b in my equation anymore. Because the whole idea is that the original one is supposed to match my new one. My new one is a reduced form of this. So if I couldn't put 0 in here, I can't put 0 in here for b. Does that make sense? Same thing for a. Even though there's no a's left on the bottom, I couldn't put 0 into the beginning equation. Again, the expression. And that means I still can't put zeros in down here, even though there's no a's on the bottom. Is everybody good with that? All right. Take out the homework and do the first 3 problems. 1, 2, and 3. Do numbers 1, 2, and 3 right now. I'll be right there, Ralph. All right. So looking back up here, let's look at 1, 2, and 3. 1, 2, and 3. Let's find you guys. Number 1. What did number 1 reduce to? David S. 4 over 5. Is everybody good with that one? So 4 over 5 is correct. Now, what about excluded values? Let's see here. Samuel, what can n not be? 0. N cannot equal 0. Number 2. So, Isaac, I know we were just talking. Do you see any variables that are on the top and the bottom? The same variable. Which one? So we got x's on the top and the bottom. Those are going to reduce. Jack S, how many x's are left over and where are they?
There's 2 x's on top.
2 x's left on top. And then Olivia, what about the y's? Do they reduce?
It's y and y to the negative.
All right, so Olivia is saying it's y to the negative 3rd power, which is correct. But the way they're going to want us to write it, if you look at the instructions, I think it even says avoid negative exponents. It wants us to write them with positive, so this is the way we want to write that. Does that make sense to everybody? X squared over y cubed. Now we need the excluded values again. What can my variables not equal? Sydney, what would our excluded values be? X cannot equal 0, y cannot equal 0. There's my answer for number 2. And then number 3, see a little bit of what's going on there for later. Let's reduce number 3 here. Tim, did you reduce this? What did you get for your final answer, Tim? Anybody got anything different than that? Nope, I think most of you got that when I was just walking around. That looked good. But we do need excluded values again. So Kalia, can you give me some excluded values here? A cannot be 0. Yep, all 3 of them. None of them can be 0. Are we good there? Okay, back to the notes then. Let's see, is this going to work? No, it's not. That's too bad. And my little thing is still not compressing itself. There we go. Now it's working. So on to number 3. Number 3, we've got to set it up. They tell us that this should be g of n over f of n. G of n over f of n. So I'm going to put g of n on the top. So 36a cubed divided by, let's put f of n on the bottom. Let's get a color that we can actually read there. So f of n on the bottom, 18a squared minus 9a. Now, right away, some of you might see 36 over 18 and want to simplify that. The problem is that the bottom has a subtraction sign in it. So let's think for just a moment. If I have 10 divided by 6, what is 10 divided by 6 reduced to? 5 over 3. And the way we are getting that is 5 times 2 over 3 times 2. The 2's canceling out, and we've got 5 over 3. Does everybody agree that that is what 10 over 6 makes, what it reduces to? So I'm actually kind of glad that I heard that 4 back there, because that's actually what I'm going to show you. 10 over 6. What if I made that 10, 6 plus 4? Everybody agrees that 6 plus 4 is 10, right? Over 6. Can I cross these 6's out and say my answer is 4? Whoa, whoa, whoa. But you just told me that 10 over 6 is 5/3. 5/3 is not the same thing as 4. Okay. This is a separate example. I'm showing you what's going on with a fraction. This right here, this does not work, guys. Does that make sense? If I cancel that 6 out, I get a different answer that is not the same thing as what I started with. 10 over 6 and 5 over 3 are equivalent. They are the same. Does that make sense to everybody? 10 over 6 and 5 over 3 are equivalent. They mean the same thing. 4 is not equivalent with those. And the reason this did not work is because when I have an addition or a subtraction, it links the two numbers together. So the 6 plus 4, I cannot cancel out either of those pieces because they are linked together by that plus sign. I cannot cancel them out unless I can cancel out the entire thing. We need to get this down right now. If there is two pieces added or subtracted, do not cancel one of them without the other. So right here, we just saw what happens if you do that. If you cross this out, you get an answer that is wrong. It is not the same as what we started with. So what we are going to try to do, and I'm going to say it multiple times today, we're going to make sure that we do not cancel out pieces that are added or subtracted together. If there's an addition or subtraction, those two pieces are locked together into one block. They move together. So right here, this 36a cubed, 8 over 18a squared minus 9a. That bottom has a subtraction sign. Does that make sense to everybody? I cannot cancel out parts of it because of that subtraction sign until I factor it. I need to factor first. So let's look at this. The 36a cubed. Now, you guys, I'm going to go a little overkill with this first one. I'm going to break it all the way apart. Most of you won't have to go to this much detail on most of these problems. But so you guys can see everything that we're doing. 36 is 3 times 3 times 2 times 2. Is everybody good with that? That 3 times 3 times 2 times 2 makes 36. Okay. And then a cubed means a times a times a. Okay, so that's all the factors, all multiplied together on the top. That makes 36a cubed. On the bottom, I'm going to factor the bottom out as well. So I'm looking at this, and I see 18a squared minus 9a. Is there something that goes into both of those? 9. I'm going to take out that 9. And can I take out an a also? A little bit bigger, 9a. And then left over, I took out 9a from this. So there's going to be a 2a left here. And I took out the entire 9a right there. So I'm going to take out a 1, or I'm going to leave a 1 in its place. There's nothing left. And let's go one step farther. This 9, I'm going to write it as a 3 times 3. Okay? This is completely factored now. But what I need you guys to see is that this block right here, the 2a minus 1 needs to stay together. That is one block, one piece. I cannot mess with it once it's been factored all the way out. It stays together. So now, though, do I see other things that are on the top and the bottom multiplied out times other things? Specifically, the 3 and 3. I have 3's on the top and bottom. 3 divided by 3 is 1. Are we good with that? 3 divided by 3 here, also 1. And then a divided by a is 1. All of those reduce. And so what I'm left with on the top is 2 times 2 and a times a. Let's try that again. And then on the bottom, I'm left with just the 2a minus 1. If it helps you, keep that 2a minus 1 in parentheses. If it helps you, keep the 2a minus 1 in parentheses to show that it stays together. But it's not the parentheses that are important. It's the minus sign. The minus sign is linking the 2a and the negative 1. This now is my answer. I can clean it up a little bit. I can rewrite this 2 times 2 times a would be 4a squared. All divided by 2a minus 1. This is my answer right now. That is as simplified as it can be. I cannot cancel or simplify the 2 and the 4 right here. Because while the 4 is multiplied by stuff, The 2 is multiplied by a, and that term is part of a subtraction. 2a minus 1. Yes, Michael.
You can just divide it all by 9a. Get the answer left right here.
That's what we're going to do from now on. Yes.
Oh,
That's why I said most of you are not going to do this, but I want you to see what's going on. Okay. So before we move on, though, we have one more task. We need to find the excluded values. To find the excluded values, go back up here. Look at the factored form and decide what would make it 0. So this a right here, this a, if I put 0 in there, the whole bottom becomes 0. So a cannot equal 0. The 2a minus 1, this piece right here, 2a minus 1. So the 2a minus 1, I need to know what makes that 0. If I'm not sure, I can do 2a minus 1 and set it equal to 0. I can add 1 to both sides. 2a equals 1. I can divide by 2. And yet a is 1 over 2. But again, I want it to not be 1 over 2. That's what it cannot be. Now, what I just did there, setting it equal to 0, solving, that looks like something we were doing last unit. What does that look like? What does that remind you guys of? Think about it for just a moment. What were we doing just last unit? Sure.
Vacation insurance is easy.
Just be like, she wants to live in the office. You know where that is?
I know where that is. I'll figure it
It's
out.
over there, right? In the 700 building. So
Yeah.
I'm thinking-
700 building right over there, kind of like on the other side of the main office. There should be a nice sign there. Yeah.
Water.
Yep. So, anybody remember what it was? Yeah. Finding the zeros or the x-intercepts. Does everybody remember doing that last unit? We set each piece equal to 0, we solve each of them, we get all the x-intercepts or zeros. It's the exact same process here, but what we're finding are the excluded values. So our answers, we describe it differently, but it's the same process. Anything that makes the denominator 0 is an excluded value. So here is our final answer. Here are our excluded values, what a cannot be. Now, some of you, again, are realizing that was a lot of work for something that could have been much simpler. So let's try another one. Number 4. Both the top and the bottom have subtraction signs on them. So I cannot cancel out pieces of them. That top piece, x minus 1, is all one piece. It needs to stay together. The bottom, both of them have a 5. So I can simplify, or I can factor out a 5 and be left with x minus 1. Before I go any farther, this is as factored as it can be. This is where I should check for excluded values. So what would make the denominator 0 here? Positive 1, the opposite of what's in here. X minus 1 means x cannot be 1. There is my excluded value. Now, one of the other teachers calls these factors that are exactly the same identical twins. If that helps you remember it, I'm looking for the exact same factor. If it's all the same, then I can reduce it to 1. X minus 1 over x minus 1. This whole piece right here reduces to 1. Does that make sense? That whole piece reduces to 1 because, again, I was able to do the entire block, x minus 1 over x minus 1. So this leaves me with 1 over 5. Okay? Are we good there? So there's my answer. Here's my excluded value. Let's do another one. This one. Okay, we have to put this one together. They didn't start it for us. So they say f of x minus 3 divided by f of x squared minus 9. So right here, I'm looking at f of x. F of x is 5x. So they're telling me 5x minus 3 over 5x squared minus 9. So 5x minus 3, 5x squared minus 9. The bottom part, yes. Not quite. The bottom part here. So, okay, real quick, were you talking about squaring the whole thing or just the bottom? So the trick is that we don't have it equal to something, so I can't like take the square root of both sides. So what we're going to do instead here, we're going to factor as much as we can every time. Yes. Either, let's do Michael first.
Last year,
Uh-huh.
we did like something like this. There's negatives on the bottom.
We
There's
moved
at
it
the
up.
top. And there's things on the top, the bottom.
For negative exponents. Yes.
Oh.
Not for negative numbers. So we're going to get to that. Yes. And that was that rule. That was that rule that we just talked about. Was it the same question? Okay. So this minus 9 is just a negative 9. It's not an exponent that's negative or anything like that. It's literally just 5x squared minus 9. But this will factor 5x minus 9, 5x squared minus 9. 5x squared is literally 5x times 5x, 5x squared. 9 is 3 squared, right? So that's a difference of squares. So this is going to factor into 5x minus 3 times 5x plus 3. All divided by 5x minus 3. So literally, we're factoring the top and the bottom as much as we can. And then we're looking for those identical twins. But first, once it's factored, before we simplify, find the excluded values. So I have two factors on the bottom. I'm going to set each of them equal to 0. 5x minus 3 equals 0. I can add 3 to both sides. 5x equals 3. I can divide by 5. I get x is equal to 3 over 5, but really that's what x cannot be. X cannot be 3 over 5 because it would make me divide by 0. And same thing, if I do 5x plus 3 equals 0, subtract 3, 5x equals negative 3, divide by 5, divide by 5. X cannot equal negative 3 over 5. Those are my two excluded values. Yes. Yep. If you want to write that as plus or minus 3 over 5, that is fine. As long as you have both. Now we can look at our factored form and decide, do I have any identical twins, top and bottom, anything that is exactly the same that I can simplify? So the 5x minus 3, this all becomes 1. 5x minus 3 over 5x minus 3 reduces to 1. And I'm left with 1 over 5x plus 3. So there's my reduced fraction, my reduced rational, my equivalent rational expression, along with my two excluded values. Does anyone have any questions on that one? Okay, I want you all to try number 7 in the homework right now. Everybody try number 7 in the homework. Give you 2 minutes. So for number 7, let's all check our work. I walked around, I saw some of you, it was looking pretty good, but let's make sure we all got the right stuff. 3x minus 2 over 3x squared minus 4, right? Is everybody good with the initial setup? Then we factored it. This became 3x minus 2 over 3x minus 2 times 3x plus 2. What are our excluded values right now? Who found the excluded values here? Sam, give me one, and then Kalia can give me the other one. What was that 2/3, 2 over 3, and negative 2 over 3. So you need to have both of those listed, whether you do plus or minus, you list them both like this. whatever you want to do, we need both of them. Then the 3x minus 2 factor, is everybody good with the 3x minus 2 factor becoming 1? I have the same entire factor, 3x minus 2. That will simplify to 1 because I have the exact same factor on the top and the bottom. So this all becomes 1 over 3x plus 2. Oops. You can put that bottom in the parentheses or not. It doesn't matter. All right, now back to the notes. Back to the notes. Number 6. Let's keep going. Ask if you have questions, but stay focused. All right, guys. We've got a lot to do here in about 15 minutes. So for this one, the top's already taken care of. The bottom. Do we all agree that I can take a 3x out of both terms on the bottom? So top, x minus 3, bottom 3x times x minus 3, right? That's what's left over when I take a 3x out of both of those. Right here is where I check for my excluded values. X cannot equal 0, right? That would make this 0. Or positive 3, because that would make this one 0. X cannot be 0 or 3.
So we're back on the notes, right? Does that make sense?
So once we've got those, now I can simplify. I see that x minus 3 factor on the top and the bottom. This all reduces to just 1. I'm left with 1 over 3x. Now again, even though now I could put 3 in and get 1 over 9, 3 is still an excluded value because it made my original function an error. And these are supposed to match. This, what I just found, is supposed to be a reduced form of this one. So anything that didn't work for the first one shouldn't work for this one. But that one's finished. Sorry. That is my answer and my excluded values. Let's do another one. This, if you turn the page and look at number 7, this is the core of what we're doing today. This is the main idea. I have a polynomial on the top and a polynomial on the bottom. I can factor both of them. Now, you guys, a lot of this unit, I'm going to be factoring them quickly. If you are having trouble factoring, come and talk to me. Come in during lunch, come in after school, get help with factoring because it's going to keep coming up. We're going to do it a ton. The top is a difference of squares. X minus 2, x plus 2. The bottom, 3 terms. I'm looking for something that multiplies to -8 and adds to -2. Yeah, it's exactly like what we've been practicing. So -4 and 2. Does everybody agree? X minus 4, x plus 2 multiplies to -8 and adds to -2. Right here, I'm going to pause and check what are my excluded values. What would make me divide by 0? What do you guys think? What are some numbers that would make the bottom 0? -2 and +4. What about +2? +2 would make this piece 0, but it's not on the bottom. And so that's okay. Having 0 on the top just means my answer is 0. An answer of 0 is fine. An answer of error is not. Does that make sense? Zeros on the top are fine, not on the bottom. So now I have one set of identical twins right here. They reduce to 1, and I'm left with x minus 2 over x minus 4. Now, in the other classes, I kept going just to see if they would catch it. I crossed out the x's, right? X over x. -2 divided by -4, that's 1 over 2. And I watched to see how many people I saw kept copying. This doesn't work. Does that make sense? I cannot do that because both the top and the bottom have a subtraction. That x minus 2 and the x minus 4, each of those is a brick, a block that stays together. I cannot cancel out just a part of it. This is my final answer. That is as simple as it gets. Yes. So the parentheses in this case are entirely optional for the top and the bottom. Put them if they help you, leave them off if you don't want them. If it helps you remember that this is one piece, put them, but they are not necessary. All right, we're going to skip number 8. All my classes have skipped number 8 because it's literally the same thing we've been doing. And we're going to look at number 9. Okay, so number 9, we learned this before. These are almost identical, but the bottom one is opposite and switched. We learned a trick earlier to make these match. And that was to factor out a -1. Take a -1 out of the bottom. So if I do that, -1 on the outside, that makes the x positive and the 3 negative. The top stays the same. I should check for excluded values. I have that x minus 3 on the bottom. That means x cannot equal +3 because that would make me divide by 0. Then I can reduce. These two are exactly the same. They reduce to 1. And I'm left with just essentially 1 over -1 or just -1. That's my answer. It's kind of funny. We're saying my answer is -1, but x can't be 3. Even though there's no x there, I still need to say it. Does that make sense? I need to show that excluded value. Just a couple more examples here. Hopefully everybody's got that one down. Now we're going to use it in this one. The top part, 4 minus x squared. 4 minus x squared. I'm used to it being x squared minus 4. Does that make sense? So I'm going to take a negative out, make it -1, x squared minus 4. That x squared minus 4 then is a difference of squares. X minus 2, x plus 2. The bottom has that 7 that goes into both terms. Factor that 7 out. X minus 2. Stop right there and check for extraneous solutions. What's the one number x can't be?
2.
So it can't equal 0, which means I shouldn't put in 2. X cannot be 2 because it would make me divide by 0. So x cannot equal 2. And then once I've got that, the x minus 2's reduce to 1, and I'm left with just -1 times x plus 2 over 7. Yes. If you wanted to, you could. The question was, could I multiply the -1 back in? Yes, you could. Either one is fine. It doesn't matter which one you choose to do, whether you leave it like this or multiply the -1 in. Those are both correct. Now for number 11. For number 11, this one, if there are 2 variables and addition or subtraction, you do not need to find excluded values, okay? Because it gets a little too complicated for what we need to do here. 2 variables and a plus or minus, you don't need to find excluded values. Here though, top looks like I can take out a 2, leaving me with a 2x minus 3y. Bottom, I can take out a 4, leaving me with a 3y minus 2x. So close, but they don't match. But I can take out a negative. So factor that negative out. I'm going to do it on the bottom. You can do it on the top or the bottom. I'm going to leave the top as it is. 2 times 2x minus 3y. And I'm going to take out a negative on the bottom. so that then it becomes a positive 2x and a negative 3y, right? Factoring out a negative out of both of those so that I can switch their places and their signs. Now the 2x minus 3y, that whole block shows up on the top and the bottom. It simplifies down to 1, leaving me with just 2 over negative 4, which is just negative 1 over 2. That is my answer. So again, once you get that block to be exactly the same on the top and bottom, it reduces down to 1. Let's do one more now. Last one. This is the hardest it's going to get of this type. The top is set up for factoring by grouping. It's got 4 terms. So I look at the first 2 and say, well, they share a y, leaving me with a y minus 3 after I factor that y out. The second 2 right here, they share a 5. I'm actually going to take out a negative 5, leaving me with a y minus 3. Now I have y minus 3 for both of them, right? Factoring by grouping, 2 sets of parentheses, exactly the same. That factors out. And in another set of parentheses, I put whatever was multiplied by y minus 3. So y minus 3 times y minus 5. The bottom is from unit 2, sum or difference of cubes. The poster's still back there. You've got it in your notes. You need to know how to factor cubes. So that 125 is 5 to the 3rd power. So I'm going to do the same sign, y minus 5. The y squared opposite sign plus the 2 multiplied together, 5y. And then the last one, always positive, squared. If you never figured out how to do factoring cubes, you might want to go back and look at your notes or come in and ask questions, because it's going to show up every once in a while this unit also. Not a ton, but it's going to happen. Now, I have an excluded value here. I know x cannot be 5. There's actually 2 more excluded values from this guy, but they are imaginary, okay? If I need you to find the imaginary excluded values, I will tell you. For now, don't worry about them, okay? We'll do that practice later. But right now, I see a y minus 5 here. Don't put stuff away. I need to show you one more thing. I'm not going to give, I know we're almost out of time, but I need to show you one more thing. Y minus 5s cancel. Left with y minus 3 over y squared plus 5y plus 25. That would be my final answer. Everybody look at the homework now. For the homework, it's 2 through 18 even. I cut it down so you guys, I know we didn't have tons of time to work in class. You've already done some of those problems. But what I want to show you is just some hints. A couple of hints on the homework. Specifically, number 6. Again, I hope you still have your homework out. I'm trying to help you out. Number 6, 3n squared. You're factoring by guess and check. 3n something, and then n and something. So again, factoring by guess and check there for number 6. For number 8, set it up. G of n over f of n. 2n minus 8n squared over 4n. Make sure you can set it up. Number 12, again, set it up. F over g. And number 14, this is the other one that I wanted to make sure everybody saw. Right here, 8 minus 2x minus x squared, factor that negative out. Negative x squared plus 2x minus 8. Okay, guys, I'm a little disappointed that we've got so many of you packing up before I'm done. You guys your tests are graded. Some of you, this is not for you. Some of you did awesome. Others, you cannot afford to be like, 5 minutes left of class, I'm done. So you guys stay focused, get the homework done. I will see you on Monday.